I really don't know why many Jambites are failing this physics question on the board. Now, this question came out last year, and so many persons failed it. If you are writing a Jamb examination this year, since Jamb repeats questions, imagine you come across this question in your computer. How well are you going to solve it? Let's see if we can do it. Now, the question is, in the diagram above, the hanging mass M2 is adjusted until M1 is at the verge of sliding. Okay, that is this mass that is hanging M2, we are pulling it down until this guy starts what down sliding. Okay, the coefficient of static friction between the mass M1 and the table is, that is always the coefficient of static friction between this guy and the table. To solve this question is very easy. First is first, I want you to attempt the problem. So pause the video and drop your answers in the comment section. I'm guessing you have paused the video, okay, by now, okay, and you have dropped the answer in the comment section. Okay, you can now replay the video and see how we are going to solve it. Now, I'll read the question again. In the diagram above, the hanging mass M2 is adjusted until M1 is at the verge of sliding. The coefficient of static friction between the mass M1 and the table is what? Okay, now to do that, we have to analyze this whole diagram. First is first, there is a rope that is connecting these two masses together. Now, we already know that this guy is going to have a weight that is acting downward. Okay, it's going to have a weight that is acting downward, which is what now? M2G, that will be the weight, right? And let's call it W2. Okay, now since this guy is coming downward, okay, there will be a tension acting on the string in the opposite direction. So the tension is going to what now? Act in the opposite direction. Let's call the tension what now? T, or let's call it T2. Okay, now if you come to this other one, if this guy is at the verge of sliding, it means there will be a reaction in the opposite direction, right? That's friction. Okay, so the frictional force will be going in this direction. That is F arrow what now? 1, because it's for mass 1. Anywhere I attach 2 for mass 2. If I attach 1, it is for mass 1. Okay, now if there's a frictional force, it means there's already a pulling force in this direction, okay, from the tension. That's what now? T1. Notice how I did not take note of the weight in this case. Why? Because the weight is acting what now? Vertically downward. Okay, it's not going to affect in this case. Okay, so we're only dealing with what now? The variables that I just brought out. Let's now analyze. Now, let's now apply Newton's law and equilibrium analysis for this particular problem. Since tension is going towards this place and friction is going towards this place, the difference will give us, so I'm going to have C1 minus frictional force 1 is equal to what now? Mass M1 times its acceleration. Okay, times its acceleration. Now, what about this other one? We are going to have W2, okay, W2 minus C2 is equal to what now? M2A. Okay, notice that since they are connected with the same string, they are going to have the same acceleration. Okay, but watch, they said it is at the verge of sliding. That's what the question said. Here it is. Let me underline it. The question said it is at the verge of sliding. Take note of this key point. Take note of this key point. So Jamb does not play with them. Verge of sliding. Now, since it is at the verge of sliding, it has not started sliding. It means the acceleration of the body is equal to what now? 0. Okay, so which means A is equal to 0. A is equal to what now? 0. Anything multiplies 0 is what now? 0. So our new equation becomes C1 minus F arrow 1 is equal to 0. Okay, W2, okay, minus T2 is equal to 0. Notice another thing again. The rope are having the same tension. Why? Because they are the same rope. Okay, the same string connecting them. So T1 will be equal to T2. Take note again. C1 will be equal to T2. Not all cases, so, but take note. For this case, because we are having the same rope, C1 will be equal to what now? T2. Now, let's now represent it as what now? T. So we can come to this equation. I am going to write T1 as T, T2 as T as well. We are now going to be left with C minus. Now, instead of writing this frictional force, we know that frictional force generally is equal to coefficient of friction times what now? Weight, right? So for this case, F1 will be what now? Coefficient of friction, okay, times the weight in this case is M1, okay, times gravity equal to what now? 0. Okay, now, how about this other one? What is the weight of W2? That's M2G. So I'm going to have M2G, okay, minus what? C2, we're representing it as T is equal to what now? 0. Let's call this equation 1. Let's call this equation 2. Now, from equation 2, we can make T the subject. So T is equal to M2G. Let's now substitute into equation 1. If we are substituting into equation 1, we are going to have M2G, okay, minus coefficient of friction times m1g is equal to 0. From here, they want us to find coefficient of friction, all right? Static friction, that's what the question is saying. Coefficient of static friction. So we are looking for what now? Mu. Let's now collect like things. We are going to have m2g is equal to mu m1g. Let us make mu the subject. So mu is equal to m2g over m1g. G can cancel g, right? We are now left with mu is equal to m2 over m1. Ladies and gentlemen, this is the answer to the question. That is m2g over m1, which is option m2 rather over m1, not m2g, because the g cancelled that, which is option what now? C. Very, very easy and a technical question. Now, the good thing about learning this whole procedure is that you know how to solve it. And then when you encounter a problem like this, it is always the same for a case like this, even if they put values. If, for example, they said the mass of this guy is 2 grams, the mass of this guy is 10 grams. Okay, this one is 2, this one is 10. And that's the find coefficient of friction. Instead of solving this whole thing again, because you already know how to solve it, you will just come here and put the mass of m2, which is what now? 2, the mass of m1, which is 10, and you answer what now? 0. What now? 2. No units, because it's coefficient of friction, right? 0.2. Very, very easy. So in less than 10 seconds, you can solve an easy question like this in Jamb exam. Ladies and gentlemen, there's always more to learn in the Jamb examination. Now, if you are preparing for the Jamb examination or WAEC examination in 2026, we have online classes where you can learn all of these things, not just physics, but as well chemistry, physics, math, not just the sciences, but arts classes, social science classes that contains government, CRF, literature, and all of it. To be part of our online classes, all you simply have to do is give me a direct message on WhatsApp via this phone number on the screen, or swipe down to my page.
So what you're going to do is you're going to click on the link on my bio. Once it shows this page, don't click on any of these links because TikTok does not allow you to click on any of these links. You're going to go to this top right corner and then click on these 3 dots. Once you do that, it opens some menu. We are going to say reports, open in browser, copy link. Click on open in browser. Okay, it will show you a new menu containing the same set of links. You are going to click on any of these links and it will be easily accessible. You can choose to join the free WhatsApp channel directly by clicking on the WhatsApp channel. You can join, and then you can choose to message me on WhatsApp using this message as a flash on WhatsApp. Join our free YouTube classes by clicking on this third link, and to access our free past questions and books for Jamb examination, you can click on the 4th link that you are seeing here. Okay, for example, to join the WhatsApp channel, you can click on it directly and you'll be given access to the WhatsApp channel.
So there you go, guys. If you have any more questions, feel free to drop it in the comment section. I'll respond to it as usual. Don't forget to like this video if you did learn something from it. Of course, I'm sure you learned something from it, okay? And also share with your friends and follow for more updates.